Hi everyone, I am JULKA. Today in differentiation we will talk about how to differentiate a function when it is given in parametric form. Question 1. Find dy by dx where y equals to a sin theta and x equals to b cos theta. Here y and x both are function of theta. So first of all we will differentiate respect to theta. Y is a sin theta. When we differentiate respect to theta, both sides we will get dy by d theta equals to a as it is and the derivative of sin is cos theta. X is b cos theta. When we differentiate respect to theta both sides, we will get dx by d theta equals to b as it is and the derivative of cos is minus sin theta. Now dy by dx equals to dy by d theta multiplied by d theta by dx. The value of dy by d theta is a cos theta and the value of d theta by dx is minus 1 upon b sin theta. After simplification, we will get minus a by b cot theta. Next question. Find dy by dx where y is equals to tq and x equals to 1 by t square. Here y and x both are function of t. So we differentiate respect to t. Derivative of y is dy by dt is equals to 3t square and the derivative of x is dx by dt which is equals to minus 2t raised to the power minus 3. Now dy by dx equals to dy by dt into dt by dx which equals to 3t square multiplied by minus 1 upon 2t raised to the power minus 3 and the answer is minus 3 by 2 t raised to the power 5 after simplification. Next question. Find dy by dx where y equals to a e raised to the power theta multiplied by sin theta plus cos theta and x equals to a e raised to the power theta multiplied by sin theta minus cos theta. Again here y and x is a function of theta. So we will differentiate respect to theta. So derivative of y is dy by theta a into e raised to the power theta as it is. Derivative sin is cos and the derivative cos is minus sin plus second function as it is and the derivative first is a e raised to the power theta. Take a into e raised to the power theta common and we'll get cos theta minus sin theta plus cos theta and after simplification we'll get a into e raised to the power theta into 2 cos theta. When we differentiate x respect to theta we'll get dx by d theta. In the right hand side we'll get a into e raised to the power theta as it is and the derivative of sin is cos and the derivative of cos is minus sin plus second function as it is and the derivative first is a into e raised to the power theta. After simplification we will get a into e raised to the power theta multiplied by 2 sin theta and now dy by dx equals to dy by d theta into d theta by dx. And the value of dy by theta is 2a into e raised to the power theta cos theta divided by 2a into e raised to the power theta into sin theta and after simplification we will get answer cot theta. Next question. Find dy by dx where x equals to e raised to the power t plus e raised to the power minus t divided by 2 and y equals to e raised to the power t minus e raised to the power minus t divided by 2. The y and x both are function of t, so we will differentiate respect to t and we will get in the case of y dy by dt equals to e raised to the power t minus e raised to the power minus t into minus 1 divided by 2 which equals to x. And now when we differentiate x respect to t we will get dx by dt equals to e raised to the power t plus e raised to the power minus t into minus 1 divided by 2 and which is equals to y. So dy by dx equals to dy by dt into dt by dx which equals to x divided by y. Next question. Find dy by dx where y equals to cos cube t divided by the root of cos 2t and x equals to sin cube t divided by the root of cos 2t. Here y and x both are function of t. First we differentiate y with respect to t and we will get dy by dt equals to in denominator root cos 2t whole square which is cos 2t in numerator root cos 2t as it is, and the derivative of cos qt is 3 cos square t into minus sin t, minus cos qt as it is, and the derivative of root cos 2t is 1 upon 2 root cos 2t into minus 2 sin 2t. Now multiply numerator and denominator both by root cos 2t, and we'll get cos 2t multiplied by minus 3 cos square t sin t plus cos cube t multiplied by sin 2t, which is equals to 2 sin t cos t, and the whole divided by cos 2t whole raised to power 3 by 2. Now we'll take minus sin t cos t common, and we'll get 3 cos 2t into cos t minus 2 cos cube t, and the whole divided by cos 2t raised to the power 3 by 2. Now we put the formula of cos 2t, which is 2 cos square t minus 1. And after simplification, we will get minus sin t cos t whole multiplied by 6 cos cube t minus 3 cos t minus 2 cos cube t whole divided by cos 2t raised to the power 3 by 2. Now dy by dt equals to minus sin t cos t whole multiplied by 4 cos cube t minus 3 cos t whole divided by cos 2t raised to the power 3 by 2. And the formula of 4 cos cube t minus 3 cos t is cos 3t. Similarly, we will get dx by dt, which equals to sin t cos t whole multiplied by sin 3t whole divided by cos 2t raised to the power 3 by 2. Now dy by dx equals to dy by dt into dt by dx, and after simplification we will get answer minus cos 3t divided by sin 3t, which equals to minus cot 3t. Next question. If y equals to a sin t and x equals to a in bracket cos t plus log 10t by 2, find dy by dx. Here y and x both are function of t. So first we calculate derivative with respect to t in case of y. Y is a sin t. Differentiate respect to t both sides, and we will get dy by dt equals to a as it is, and the derivative of sin t is cos t. In case of x, when we differentiate respect to t both sides, we will get dx by dt equals to a as it is, and derivative cos is minus sin t, derivative log is 1 upon 10 t by 2, and derivative 10 is sec square t by 2, and the derivative t by 2 is 1 by 2. After simplification, we will get a times of minus sin t plus cos t by 2 divided by sin t by 2 whole multiplied by 1 upon cos square t by 2 into 1 by 2, which equals to a times of minus sin t plus 1 upon sin t. After LCM and simplification, we will get answer a cos square t divided by sin t. Now dy by dx equals to dy by dt into dt by dx. The value of dy by dt is a cos t, and the value of dt by dx is sin t divided by a cos square t. And after simplification, we will get answer 10t. Next example. Find dy by dx where x equals to cos inverse 1 divided by in the root of 1 plus t square, and the y equals to sin inverse t divided by the root of 1 plus t square. Here y and x both are function of t. First we put t equals to tan theta in both cases, and we'll get y equals to sin inverse tan theta divided by in the root of 1 plus tan square theta. 1 plus tan square theta is sec square theta in the root, so we have tan theta divided by sec theta, which equals to y equals to sin inverse sin theta. So this is theta, and the value of theta is tan inverse t, and differentiate respect to t is dy by dt equals to 1 divided by 1 plus t square. In case of x, cos inverse 1 upon 1 plus tan square theta in root. 1 plus tan square theta is sec square theta, and when we cancel the root, we have sec theta. This is cos inverse cos theta, and so x equals to theta, and the value of theta is tan inverse t. And when we differentiate respect to t both sides, we will get dx by dt equals to 1 divided by 1 plus t square. Now dy by dx equals to dy by dt into dt by dx, and we'll get the answer 1. Next question. Differentiate x cube with respect to x square. Let y equals to x cube and z equals to x square. Now we have to find dy by dz. dy by dx equals to 3x square and the derivative of z with respect to x is dz by dx equals to 2x. And dy by dz equals to dy by dx multiplied by dx by dz. And after simplification, we'll have answer 3x by 2. Last question. Differentiate sec x with respect to 10x. Let y equal to sec x and z equals to 10x. Now we have to find dy by dz. Here, dy by dx equals to sec x 10x and dz by dx equals to sec square x. So, dy by dz equals to dy by dx multiplied by dx by dz, which equals to 10x divided by sec x, which equals to sin x.